Hello and welcome to the third session of HATS Distance Learning Workshop organized by Royal Cyber. I am Asif Hussain and with me I have Muhammad Imran, a senior HATS developer. Attendees can post questions in the GoToMeeting chat window or ask them verbally at the end of session or ask me to open their microphone at the end of session. So let's discuss a bit about what are screen events and transformations. We're getting a bit technical into the HATS development, and here we'll have a chance to understand how HATS engine works, how it transforms the green screen applications into web applications, what is its strategy, what is its algorithm of handling the things. So understanding these things will help you design better solutions for your clients and help you understand the underneath process that is handling the situation. So there are actually two types of HATS events, application events and screen events. Application events are auto-fired by HATS. They can be error events or busy event fired in case HATS engine finds host busy. Like if on web you create some request, you provide some inputs, you provide some command inputs, and these inputs are not yet fully processed by the host application, host green screen application. And since the web page is available to the user, he orders something else. He clicks on some other option. So in that case, when HATS fires that or conveys that option to the host system is busy doing something else. Maybe it is processing some macro, traversing through some screens. So the web interface that is presented by HATS will show a busy screen. So this is busy event. To understand screen events, let's see how HATS engine work. And for that, we need to see what is screen recognition criteria. That's a pretty useful concept in this HATS development, and we should understand this first. Developer sets screen recognition criteria that HATS uses to match host screens. Host screens can be recognized by any combination of criteria, including how many input fields or total fields are on the screen, the coordinates of the cursor's position, and text strings present on the screen, within a defined rectangular area or anywhere on the screen. So anything on the screen, on a particular screen, can be treated as a screen recognition criteria. So for defining such a screen recognition criteria, what a developer does, he goes for a string or anything that is unique on the screen, that by that unique string or input field or anything, the HATS engine can recognize that this is the screen where HATS should apply a particular customization or particular trigger should be fired. When a host displays a screen, HATS searches to see whether the current host screen matches any of the screen recognition criteria you set in your screen customizations in your project. If HATS finds a match, the defined actions for the screen customization are performed. So in short, looking at the whole picture here in the flow diagram that you can see on the screen, when the host displays a screen hats compares the host screen to each screen recognition criterion defined in the project's enabled screen customizations in the order defined by event priority until a match is found. When a match is found, HATS performs the actions defined for the screen customization. These actions can include applying a transformation using the associated template. HATS displays any host components defined in the transformation as HTML widgets. It may execute some business logic. It may interact with some global variables. It may play a macro. Macro will be discussed on next slides. If no screen recognition criteria is matched for host screen, HATS processes the unmatched screen event. The default action of this event is to display the host screen using the default transformation and applying the default template. This is like creating a web page on the fly based on the text and fields on the host screen. As the host presents each new screen of an application, HATS begins with all these steps again and proceeds through these steps. So now let's see what is macro. We discussed that on recognizing a screen, the HATS engine may fire a macro if it is programmed to do so. So what is macro? Macros are used to automate end user interactions with the host. You can record and play macro to skip screens, prompt users for data inputs, and extract host screen information. A macro that skips screens does not require the user to interact with each screen. There's a type of macro called prompt macro. It requests information from the user that is used on other screens. This information is used on other screens, thereby limiting user interaction with the host. While an extract macro, this another type of macro which is called extract macro, can be used to retrieve information to present to the user. A macro can be played as an action of HATS screen customization, as we discussed earlier. It is the last action defined for a screen customization. Macros are foundation of a web service made in HATS. When such a web service is called, a macro is executed and it inputs certain data and replies the result. To further demonstrate and talk about this use of macro and the general use of web services in HATS applications, we are going to have a webinar session, free webinar session next month. No, this month it is. This month of November, and it is on 21st, I guess, 21st of this month. To register for this webinar, you can log into our site, just like you registered for this session. From here, Muhammad Imran will demonstrate you some of the practical aspects of this HATS development. Over to you, Imran.
Thank you, Asif. Now we will perform lab and this lab will demonstrate how macros can be executed both by user initiation and automatically upon screen recognition. Skip screen macro will be recorded to navigate multiple screens and then stop on a board's detail screen. So build a new project. For this purpose, follow the steps to build a new project. Select file and then new heads project. On the create a project panel, enter the project name, something like lab 5, and select the target server as WebSphere application server 8.0. In the enterprise application project name field, enter the name like lab 5 underscore AR or whatever you like, and leave all other as default, and then click next. On the create a project lab 5 connection setting panel, enter the following settings as you can see on the slide. Host name is iSeriesD.dfw.ibm.com. It's a demo server of IBM, and type is a 50-50 because it is a iSeries, and port for this is a 992, and leave the code page at 037 United States, and the screen size at 24 by 80, and then click the next button. On the create a project lab 5, select default template panel, select the template something like sport.jsp, click finish, and then Studio will build a new project. And now I am assuming that the SSL key file, so you have to import is as well. So I am considering that you will do it yourself. So I am skipping those steps. Note that when the studio finishes building the project heads project view will be open with the project folder on the left, and lab 5 settings open in the heads application editor. Now we have to turn off subfile support. Click the rendering tab of lab 5 setting. Scroll down if necessary until the list of transform appears. Remove the check from subfiles. Save the changes by selecting file and then save, or press Ctrl S. Now we have to sign on to the system. So right click the lab 5 project in the heads project view, and then click open host terminal, and then select man. Sign on using ATDemo, and ATDemo is the ID, and demo for you, it is a password. Note if the display program message screen appears, press enter to navigate to the i5 OS main menu. Now we have to create a screen customization. From the host terminal toolbar, click the create heads screen customization button. On the i5 OS main menu screen, on the create a screen customization, new screen customization panel, accept the pre-filled screen name like i5 underscore OS main menu, and then click next button. On a screen customization, select screen recognition criteria panel will appear with a screen capture of the i5 OS main menu screen. Use the mouse to resize the selection around the text i5 OS main menu. On the string position selection, click at a specified position. This will make the screen recognition criteria unique to this specific location for the text i5 OS main menu and then click next button. On the create a screen customization, select action panel. The apply a transformation option will be checked by default. Create new transformation will be checked by default with the name i5 underscore OS main menu.jsp, something like this. Change rendering option to pre-populated using default rendering. Leave everything as is and then click finish button. To see how the screen will appear in a web browser, go back to the host terminal and then select the host screen preview tab. Now we have to record heads macro. This section will introduce the heads macro recorder. The OS 400 main menu will be customized in order to add a button to run the macro. A skip screen macro will be created. Open the host terminal if necessary. Navigate back to the i5 OS main menu screen. From the host terminal toolbar, click record macro button. On the record macro panel, type bots as the name of this macro and then click finish button. On the define screen recognition criteria, define the starting screen of the macro panel. Use the mouse to draw a box around the text i5 OS main menu. As you can see on the slide, click at a specified position and then click finish button. Enter bots on the command line and then hit enter. The AS400 WSG bots demo menu will appear. Change the type from A to P and then hit enter. The list of powered bots will appear. Enter a 1 on the input field next to the first bot and then hit enter. The detail for the bot will appear. Click the stop macro button. As you can see, on the define screen recognition criteria, define the exit screen of the macro. Draw a box around AS400 WSG bot demo. As you can see on the slide, deselect number of input fields and cursor position checkbox and select at a specified position radio button and then click finish button. Now save the macro using save macro button. Test the macro in a transformation. Now we will add a macro button to the OS 400 main menu.jsp transformation so that by clicking on this button macro can be run. Now open the OS 400 main menu.jsp transformation by go to the heads project view of studio, expand the lab 5, then web content, then transformation folder, and then double click on OS 400 main menu to open it in the editor. Select the source view for this OS 400 main menu.jsp. Just below the heads form you can find the text, as you can see on the slide in the blue background. Delete this text and then select the design view. Place the cursor on the line below the text 90 sign off, as you can see on a slide. Vertical black line is the cursor. From the studio menu, click Heads tool, then insert macro key. On the insert macro panel, click the box next to the bots, click OK. The bots macro button will appear where the cursor had been placed. Now save OS underscore 400 main menu.jsp. Now we are going to test this lab, run on server. So right click lab 5 project and select run on server. When browser appears, sign on with user ID and password @demo and demo for you. Note, if the display program message screen appears, press enter to navigate to the OS 400 main menu. On the OS 400 main menu screen, just below the text 90 sign off, there should be a bots macro button, as you can see on a slide. Click the bots button to run the macro. The macro will run, navigate to the AS400 WSG bots demo screen and then display the bots detail. Now we will see how to enable the macro to run automatically. In the head project view, expand the screen customization folder and open the OS underscore 400 main menu.event file. Then click the action tab. Click apply a transformation in order to highlight it, and then click the remove button to remove it. Now click add button. Check the play macro action and then click next button. On the add play macro action, define action property panel, choose bots from the drop down menu. It is a name of our macro which we have created, and then click finish button. Now save the OS underscore 400 main menu.event file. Now we have to test automatically running of this macro. For this, now right click the lab 5 project and then select run on server. When the web browser appears, sign on to the system. When the OS underscore 400 main menu.event file recognize the OS 400 main menu screen, the macro will run automatically. Now I will ask Asif to continue from here.
Thanks, Imran. Now there are some other conceptual concepts, about hats we need to discuss here. And it is one of the very important things in programming hats application. This is global variable. Global variables can be used to store and retrieve data like any other variable, of course. Hats can also perform mathematical calculations on global variables. We can store end user inputs as global variables. We can use global variable to pre-fill text entry fields. Global variables contains a value that can be used to pass information from one hat's object to another, from one screen to another, in fact. For instance, you can extract information from several locations on a host screen, perform calculations, and insert the result on the current screen or on a future screen. You can build up an array of strings from one or more host screens and insert them into a transformation. Or you can extract a string that a user enters into a field on the GUI and use it elsewhere. Conceptually, global variable is a session variable. So the programmers among you, the web programmers among you, can now relate what global variable is. It's a normal session variable, just like it is on any other web programming language. A global variable that can be shared between applications is called a shared global variable in hats. If applications have to be in a if it is a single applications variable, it should not be a shared global variable then. So in fact, it will be global for only an application if it is not a shared global variable. And what does it mean? What does it mean to be shared between applications? Let me clarify it. An ER file can have more than one application. So if a single ER file has more than one application, a shared global variable can be accessed from more than one application, an ER file. If it's not a shared global variable, then only the ER file in which it is created the application it has created in can access it. So a global variable is not global in following respect. Multiple hats applications deployed on a server, multiple client accessing a hats application at the same time or at different times, or one client accessing a hats application again in a new session. In all these aspects, a global variable is not global. A global variable is global anytime during a single user's hats application session. Hats also provides full support for printing and keyboard. So what local print support is? We can establish a print session for the associated host application. When the hats application is running, a user of the application can print data or display data that is formatted for printing. And now let's discuss what native keyboard support is. By enabling keyboard support, there are different ways in which the users of your hats applications can send keystrokes to the host. For example, buttons or links for function keys that are rendered by hats default rendering. The user clicks on the button or clicks to send a host key to the host. So this concludes our Unit 3, Session 3 that covered screen combinations, hats. In this session we discussed macros, and we had a demonstration of it. We discussed about global variables. And in the next session we will discuss about screen combinations, hats, administrative console, and portal support. Now we are ready to take questions from the participants. You can type your question in the chat window, or you can ask me to unmute you so that you can ask it verbally. We have a question from Mike that what is application event? What are application events? Imran will answer this.
Actually, the rule-based approach used by hats enables you to customize screen by applying certain action upon a screen recognition event. You can also associate actions with other hats events known as application event. The application event include application occurrence such as connecting and disconnecting from the host server, starting or stopping your hats application, or when your application encounters an error or an unrecognized host screen. You can configure these application events to perform certain action when they occur.
We have another question from Tim. Tim is asking that somewhere in our presentation we said disable subfile support. So what is subfile? So a subfile is a group of records that have the same record format and are read from and written to a display station in one operation. As the term suggests, a subfile is not a file. Rather, it is a temporary place to store data of the same format to be used by a display file program. So it's kind of a table presentation or a queries result presented on the screen. And since hats provide full support for subfile modernization, we've disabled its support for our operation, but later we can use it when needed. So this concludes our Unit 3, and the question answer session is also finished. You can email us questions as well. We will take questions in the last, that is 4th session. We will take questions there as well. So you guys can follow the lab instructions and perform the labs and let us know how it helped you in doing the HATS learning. So thank you very much for joining in this session. We'll meet you in around 2 hours in the 4th and last session of this distance learning workshop. Thank you very much.
The organizer has ended the session, and this call will be disconnected. Goodbye.